Bandwidth for changelog is provided by Fastly. Learn more at fastly.com, and we're hosted on Linode servers. Head to linode.com/changelog.
I'm David Chase, and it is go time.
It's Go Time, a weekly podcast where we discuss interesting topics around the Go programming language, the community, and everything in between. If you currently write Go or aspire to, this is the show for you.
Welcome back, everybody. This is Go Time episode number 52, where we're joined by David Chase. I'm Brian Kettleson, standing in for Eric St. Martin, who is out today. I'm joined by Carlicia Pinto.
Hi, everybody.
And Ashley McNamara.
If you're filling in for Eric, who am I filling in for?
You're filling in for me.
Perfect.
Yep, I'm standing in for Eric. You're standing in for me. Carlicia is standing in for Carlicia, and David is standing in for David.
Right.
Perfect.
So, David, why don't you start off by introducing yourself, kind of giving us some background and telling us what you do?
So I guess my background is in programming languages, compilers, and programming language runtimes. This started out way back when Fortran, but now I work on Go, mostly on the Go compiler, but there is a pretty healthy runtime component to the compiler work. So, and the garbage collector, for instance, requires write barriers. The compiler has to be aware of them, and it can do optimizations involving them. The scheduling in Go is cooperative, and the compiler enforces the cooperation. And I'm already pretty much down deep in the weeds with what I do, but those examples of what the work is like. I have experience with some of the features that people talk about wanting for Go 2. So I try to contribute there too, like generics.
Nice. So can you kind of, I'm more of a business information guy rather than a computer science guy. Can you kind of give us the rundown of what components are involved in a compiler? What does a compiler do when I type in source code?
Stop stealing my questions.
Hey.
Brian.
Hey, be nice.
So it varies somewhat from compiler to compiler, but in general, they tend to have phases and they sort of mix and match. So you start with the characters. They tend to transform those into a tree-based representation. Usually they do scanning to break it into tokens and then parsing to combine the tokens into more structure. Once you have the tree, you can do a certain amount of, I think you would call it semantic analysis. So enforcing a lot of the rules of the language. Can you look at this? Can you look at that? Do the types match? And so on. And some compilers go straight from tree to code generation. And in fact, the Go compiler used to do that. I can't even remember which release it was. I guess we lit up SSA in 1.7. We added a phase. Keith Randall talked about this at Gophercon, and that talk will be online in a little while. But we added a lower level phase. It's somewhat closer to the machine code, but it is also structured, and it makes it easy to express a lot of optimizations. And it was surprisingly easy to do our ports too, when we went from supporting it on one platform to all of them. So the Go compiler, again, is characters come in, scan and parse into an AST, do semantic analysis to enforce rules, transform AST to SSA, and do a certain amount of optimization. And then we interface to the Go assembler, and out comes machine code. That's a crude description. There are certain important analyses that we do on the tree-based form still. And it would actually be a lot of work to get some of them out. Escape analysis is actually interprocedural within the package that's being compiled, and on top of all the packages that it requires. And it would be nice to move that into the SSA framework, but it would require several changes to the SSA framework. And in particular, it would require us to do the entire package at one time in SSA, which is not what it's built to do just yet.
So when you say you do escape analysis against the AST, does that mean that there are notations added to the source code somehow or to the abstract syntax tree that show the results of that escape analysis? How does that analysis move from the AST into the final generated code?
So the AST nodes, sort of an artifact. If you go look at the Go source tree, you will find two ASTs. And one of them is sort of very visible, and it's for public consumption for source code transformation. There's also the one that the compiler uses. And the one that the compiler uses, the AST nodes have a lot of extra baggage added to them to do just that, among other things, so that you can say this identifier had its address taken, therefore it probably can't go in a register. Escape analysis runs over all the identifiers that have their address taken, or all the expressions too, because you can have so at the tree level, sort of everything can have a name, even if it doesn't have a source code name.
Mm-hmm.
And so everything that could have its address taken, escape analysis looks to see where those addresses go, and not only locally tags them by saying, your heap, your heap, your heap, you're a stack, your stack, your stack. It also generates interprocedural summary information to go into the export data for the package, so that if I don't have any handy examples, but there are functions that you can call of, say, two parameters, and it says this function, yeah, you pass the pointers in, but that's okay. This function looks but does not tell, does not spread them around. So if they weren't escaping, they are still not escaping. So may have been, again, deeper in the weeds, but
no, that's where we want to go. We want to go deep.
Okay.
We have several listener questions. So we're going to start with Matt first. He said, what is a good place to get started if you want to contribute to the Go compiler?
Oh, I'm seeing the Slack channel. I wasn't paying attention.
Mm-hmm.
Rats.
It's fine. I'll read them.
So my personal hobby horse this month is that we need better benchmarks, but that's not the same as the technical work on the compiler, even though it's really important. Because our benchmarks are not the things that people run that they actually care about.
Mm.
Not all the architectures receive the same amount of attention. So if someone were, say, a particular fan of ARM or ARM64 or PowerPC 64 or MIPS, we have people who look at MIPS and MIPS 64. It's possible that there are idioms that we're getting wrong and we could do better. And so I'm thinking about what's the most accessible part of the compiler. And the most accessible part of the compiler is, to me at least, so that could be wrong, where we lower the code from generic SSA to the various architectures instruction sets. That's pattern matching, and it's pretty obvious to see what it's doing. And there have been cases where we just didn't have the right pattern for something, or we were missing a pattern. Some of them could be a little grotty, but they're not all. And that's just a good place to. It's a good place to start. You can look at it and you can understand what's happening, if that makes any sense.
That does.
So that brings up a question for me, though. Do we no longer have the intermediate Go assembler that's output? Is there still a step that outputs Go assembler, the old Plan 9 assembler, which then gets translated, or is that step gone now?
It's essentially still there. It's building internal assembler data structures. I don't think we're actually writing a file.
Oh, I see.
In fact, I know we're not writing a file.
There's a follow-up question to Matt's original question about how to contribute, and he was asking if there is any recommended reading for compiler internals?
Hang on just a second.
I'm fully expecting David to come back with the title of his book that he wrote.
Right, same.
No, I have not written a book. I was going to grab 3 books that I know of. I don't actually know if any of these do a good job of covering SSA. Okay, so we have a little one whole subchapter in Cooper and Torkson. So that's one. That's engineering a compiler.
And what you can also do, if you want to research that question a little bit, is you can drop it in the Slack channel later, and I can help remind you.
Okay, that might be a good thing to do. Wowzers. Yeah, so I have several compiler books. I know that Andrew Appel has written several in various programming languages, which might be interesting to look at if you were already familiar with a particular programming language. That is another choice.
So here's a question. Is there a compiler that people consider to be like a canonical compiler implementation, or a particularly easy to access or easy to grep compiler implementation? Like, is there one compiler that's so much nicer than all the others?
There used to be one. LCC had a reputation. It was Fraser and Hansen, but it's some of this is a little old, but it was a relatively small, relatively easy to comprehend compiler. I don't think that the Go compiler is necessarily that scary.
I don't know. It seems pretty scary to me. Like, I want you to explain everything like I'm 5.
Yeah, so the problem is I'm sitting here thinking of the compilers I've worked in, and what happens is that anything that's successful gets ported to a lot of architectures, and then as soon as it gets ported to a lot of architectures, that introduces all the generality that you need to support a bunch of architectures, and then people want it to go faster, and you start getting more and more hair and optimizations. And the Go compiler's not bad.
It's not bad.
It's not bad.
What could make it better?
Well, so this is a problem because it means better for whom. So we have stuff in the pipeline right now that is going to be, I think, way better for compile time and a little bit better for performance. So we think that if we improve the import-export again, we already improved it once. If we do it again, then we can make it more on demand and less batchy. And then that in turn will allow us to turn on inlining, what they call mid-stack inlining. And so that'll be good. We think that might make everything about 5% faster, except that it won't make compile time faster until we do this lazy import. Lazy import will be great. It ought to make compiling a little bit faster than it is right now, even with the expensive extra inlining. But from the point of view of reading the compiler, it got a little worse.
Yeah, that makes some sense. I mean, there's always a cost.
What else is in the pipeline for the compiler?
For 1.9, maybe for 1.10?
Well, yeah, 1.9, 1.10, 2.0.
So I don't know everything. I know around me, we tried to get in a CL, a big CL, that would have improved the debugging experience for optimized code. And we didn't make it. And so that is definitely in the pipeline. We want to have a better story for that. We want to, if you have to, in particular, if you have a crash and you get a dump, that's generally optimized code, which is the usual case for Go.
And what was the CL for?
Well, so when we run SSA, it tends to break up variable lifetimes into smaller chunks, and so they'll go in and out of registers. Right now they're still homed to the same stack slot, but over this basic block, it might be in a register, and then a little while later, it might be in a different register. And so we have to emit the debugging information that describes that value movement in and out of registers. So that's something that we really want to get done at 110. We have been getting more and more trouble with loop. So I mentioned that the cooperative scheduling in Go is enforced by the compiler. And right now it's kind of lightly enforced. It enforces it when you enter a function or method. But if you are running in a tight loop that has no function calls within it, it does not enforce any cooperation there. And this is a particular problem. Reese Hiltner mentioned this in his tutorial or his talk, also at GopherCon. Also, where the garbage collector needs to interrupt all the threads right at the beginning of a GC, just for a few microseconds, but it does need to interrupt all of them. And it does this by asking them to reschedule themselves. They all reschedule. They discover that a garbage collection is in process. And they go stand in a corner and wait till the GC does its thing and then says, yeah, back in the pool, go. And then there's this one guy running a tight loop. And the GC tries to tap him on the shoulder and he does not respond. And does not respond, and does not respond, and does not respond. And so everything hangs up, and it can be an appreciable fraction of your pause time for GC. And in some rare cases, it can be long. And so we need to fix that. And so we need to change the compiler to add a preemption check on every loop back edge. And the problem with that is that it slows down your loops a little bit. And some loops it slows down a lot. So there's follow-up work to try to figure out if we can mitigate this cost using a clever implementation. We have already tried loop unrolling, and for whatever reason, it was not helpful. So either we did it wrong. We probably did it wrong because we did it kind of in a very bloody-minded way. Just, take the loop, don't get smart about the indexing or anything. Just do the check over and over. I want to say make 2 copies of the body, but check after every execution of the body. So twice per loop. Whereas in many counted loops, you could say, well, I'm going to unroll by 2, increment by 2, and then I'll worry about the odd case at the end. And so we didn't do anything that clever. So that's also for 110 is dealing with that and the knock-on problems there. The garbage collector guys are looking into whether they can make generational collection work, and that will add a write barrier that's going to be on all the time, which will then motivate us to look a lot harder at write barrier optimizations. I don't know who's going to be doing that. Might be me, might be somebody else, but we're certainly motivated to look at it.
I wonder if you have a feature that is at the top of your wish list that if you had no constraint, you could implement that and make Go a ton better.
I hate to say if it had no constraints, because that's not really Go. And
Pretend it's magic.
Pretend it's magic.
Yes.
Oh man.
Maybe no time constraints or no budget constraints.
Well, so you're talking completely compatible. Are you talking about Go the language or Go its implementation?
Go the language. I just trying to assess where your mind is in terms of what you admire, like what you admire about Go, and how do you see it becoming better than it is. It doesn't really matter. I just wanted to get a sense for how you think about Go.
So if I were to say, look at the proposals that went by in the last year or so for Go 2, the one that I really kind of would love to see, that I almost thought they could have put in, I think it had syntax that would have allowed us to put it in if we wanted to, was the multidimensional slices. That's really kind of my Fortran background speaking there.
Mm-hmm.
But it's one of these things where people who don't write that kind of code think, yeah, it's easy. You just code it up. It's fine. And it's the usual thing. Anything that I don't actually have to do that someone else has to do, that must be easy. And it's really much nicer to have the multidimensional syntax. And it's really much better in terms of generating code and doing bounce check elimination if you have it built into the language. And it's tremendously useful and for a certain kind of computing. And the people for whom it's useful, this is the Fortran crowd, they've sort of been stuck at Fortran for ages. C++ has done amazing things for them, but often you have to be willing to sign up for crazy C++ templates. Go is this nice, clean, comprehensible language. It's just a little thing, and you could do. It appeals to me. Generics, like, oh yeah, generics would be cool if we could agree on what they meant. And if we could agree on their implementation characteristic of what we wanted to do, and there's all sorts of risks where it might not make it a better language.
Yeah, of course.
So, so the one for me that looked like the most likely to win would be the multidimensional slices. I liked that a lot. It didn't make it in, made me sad.
I want to flip this question around and ask you what is in Go today from a compiler perspective that you would be happy removing. And maybe that's not even a fair question because as far as functionality, Go is already so minimalist. But I was wondering if you had one or two things that you could get rid of easily.
I have, it's not a compiler thing. I have opinions about how things go back and forth to C Go, and we're close, and I think that we're converging. We may have already met, and I may have just misunderstood because I don't do enough C Go programming to get a really good feel for some of the details. Probably not even that. It's like you said, it's a tiny language. They did not put a lot of. There's not a lot of CRUD in it.
Yeah,
we like it that way.
Yeah,
we do it that way. Scott Mansfield has a question that sort of ties back into what you were talking about before, how the changes that you guys are making are not really going to affect compile time. He was asking, do you think that the speed of compilation is hamstringing the advancements in the compiler? I thought that was a good question.
So when he says advancements, he's talking about like 17 zillion amazing optimizations that we could be doing that we're not. At one level, yeah, sure. But I have worked on compilers like that. And if you want to have, so there's an aspect of Go that makes it, I want to say, this is a tricky conversation to have, but.
He says it's a loaded question, but thank you.
I mean, his question is loaded, but if you do a lot, absolutely. There are optimizations that we are unlikely to do because the implementation costs are too high. And otherwise it is just kind of a pain and you sort of live with it. In some cases, it means that it's one of these usual, three good things, choose two. Because you could make a compiler that did more optimization and also ran quickly-ish, but that often means that you would be using really hairy algorithms. And we've had to do this already. So, returning to the SSA representation, it's really interesting because it lets you express a number of optimizations in a very clean way. And it lets you express these transformations in a very clean way. But if you actually look at how SSA is generated, there is a step in there that for some inputs, the first time we did it, just caused the compiler to go 6 gigabytes, 40 minutes, that kind of crazy. And we read papers. And so we had to go and implement stuff from papers. And we have also had bugs every once in a while where someone very cleverly took a recursive depth first search numbering transformation kind of an algorithm. And they got and they de-recursed it, and they turned it into something that maintained its own stack. And they subtly perturbed the depth first search numbering. It wasn't really depth first search anymore. And you'd get these crazy bugs that you would not catch with any simple example. So again, you get a fast, you have a nice fast compiler, but some of the algorithms underpinning SSA are delicate and sneaky. And so this is the problem. It's like, yeah, if we were willing to just burn time, we could pretty easily implement some hairy optimizations, some more aggressive optimizations. But we can't burn time. So whatever we do, we have to be a lot more clever.
Right.
The other reason to prefer simplicity, I think, and this may just be me, is I think one reason to like Go right now is that you do have a prayer of understanding it end to end. Whereas, a C compiler is crazy nowadays, and a Java compiler, including Hotspot, is absolutely crazy, just bananas. And what you care about that for is for things like correctness and security. Go is not a formally verified compiler, but those are pretty rare, but they're getting less rare. And you could imagine that if we kept the language small, that maybe we'd get there someday. Maybe not this Go compiler, but another one. But even without formal verification, we at least have a chance of, reading the whole thing and understanding all the parts and how they work.
It is so refreshing to hear someone like you say that. And I actually wanted to confirm that when you were talking about simplicity, you were talking about readability.
Well, ultimately, you worry a little bit about it from the point of view of security. But, don't forget who worked on this compiler. Ken Thompson, Trusting Trust.
Yeah.
Best paper ever.
I would like for you to tell us more about what you just mentioned about, I even forgot the words you said.
The verified compiler?
Exactly. What is that?
Yes, somebody just asked that.
And why is that important?
So
I'm sorry, and why don't we have it?
So I don't have direct experience with them. So I want to be careful I don't go out on a limb and make stuff up. A verified compiler is one where you have proved that its transformations, you formally proved that its transformations are formally correct. And part of the reason that you don't have these is because if you're going to talk about actual dotted I's and crossed T's correctness, you need to have an exact specification of the input language and its behavior, intended behavior. And then you need to have an exact specification of how the hardware is going to behave. Or in the case of so much of our hardware, you have to have an exact specification of how a subset the subset that you use of the hardware behaves. So in particular, if you don't know for sure what some of these instructions do, then you don't do those instructions. So part of the obstacle is getting the specifications, clean specs for the endpoints. And then the rest of the problem is that you get back to I want my code to run fast and I want my compiler to compile code quickly. And this forces you either to have a great big, you end up with the giant compiler, you end up with the tricky algorithms, and you might not have a proof for some of them. Okay. Is that getting in the vague direction? But you've actually proved that it's going to do the right thing, and you have a proof. You don't just have testing.
It's still hard for me to grasp the why if we have verified, but we have proved it, but we don't have the test. I don't know what that means, but we don't have to go deep into those woods.
I'm just curious whether we have to verify every backend, every different target. So do you have to verify for x86 64 and also for ARM5 or whatever? Do you have to verify each different target?
Well, what do you mean? Do you want, it's verified where it's verified. And if you don't, then you don't know for sure. And, we don't know this now. I mean, we're talking about a different world than the one that we're in. The world that we're in, we compile our code and we feel lucky.
I feel lucky every time my code compiles.
Okay.
Same.
So, but there is, and certainly when you work on a compiler, there's, a lot of times I'm working with a buggy compiler because I'm usually breaking it. But I mean, right now these are only used in very high risk applications. I believe they are used. My recollection is that some of the interesting work has happened in England, and I think that some of it is used in avionics code. So real time controllers for flight surfaces and things like that.
That makes sense.
And I could be wrong on the details because I'm pretty sure that the guys doing Airbus would care about this.
So I have a follow-up question on something we talked about a little bit before, the idea of adding more optimizations at the expense of compilation speed. Do you think there's a chance that we'll end up with optimizations that are guarded by build flags like GCC has, for example?
I assume it has to happen eventually, but I think it's our intent to put it off as long as we can, because every flag that you add then becomes something that you have to test, and then every flag that you add becomes something that you have to document, and it complicates everything. It complicates your bug reporting. You have the option. What happens if you have a bunch of packages that you depend upon, and and some of them are compiled one way and some of them are compiled the other way, and then you have a bug, and then you have to report the bug. Does the bug report have to include the compilation flags for each of the packages that you have in it? I assume nonetheless that it will have to happen. There will come a time when there's enough extra performance to be had for something that's sufficiently important. But it hasn't happened yet.
So in terms of performance, I know that the LLVM ecosystem was considered very early on in Go, and it's changed quite a bit in the last 10 years since they looked at it. Is there a possibility for backend for Go and LLVM in the future?
It's being worked on.
Who?
Than McIntosh, who is, I can't see him because I've got my door closed, but he sits 20 feet that away from me. Than McIntosh is working on that. We're not there yet. And it will be a while before we get the same garbage collector. But this might be an option for people who maybe don't need the amazing sub-millisecond pause times and want higher throughput.
Would that also bring, I'm not terribly familiar with LLVM, but wouldn't it bring a lot of extra tooling too to the ecosystem?
I don't know. I'm not that familiar with LLVM either.
Okay. We'll find out someday.
Okay.
So Caleb asked the most important question, in my opinion. What kind of pie does the Go compiler team like best?
Oh, his was key lime versus pecan.
Hey, you are not limited to those pies.
No, that's a really bad subset of pies. I mean, if you don't include banana cream, then it's not even a pie question.
Wait, why is this question even being asked? Why not what kind of muffin or donuts? Why pie?
Because
is that
pie.
a joke? Is that an eternal? Okay, is that why? Okay, guys,
we can't. Right now, we're just interested in pies, but we could go into the whole pastry line.
So I can definitely say that for me, pie beats muffins and pie beats donuts.
And pie trumps.
I don't know if it beats donuts. That's easy. But
and personally, I am very happy with either key lime or pecan pie. I did once make 6 pecan pies for science, where each one was a different recipe. So I could see which one was the best recipe.
Nice.
Which one was the best recipe?
That's the problem. I forgot.
That's a big problem. You can't say that one was the best and not know.
You could say that one was the best, but not remember which one.
That's true. One
Oh,
was
yeah,
the
yeah.
best. There's no doubt that one was the best. And I think maybe the most important thing to do is make 6 pies again.
Yes, for science, of course.
For science. I do recall that the recipes with butter in them really ended up kind of slimy, and I wouldn't recommend that.
Oh, that's upsetting.
Yeah,
Okay, so pecan was the answer. Or key lime?
I like key lime a lot.
There you go, Caleb.
Pecan pie is just amazing. It's just so.
I think pecan pie has too many pecans.
How dare you?
It's just too nutty.
I know.
But I do like both of those pies. They are.
No Boston cream pie for you?
Oh,
It's okay. I mean, pie is good. I'm trying to think of which pie. Pecan has to win, actually.
I don't know. I'm all about apple a la mode.
now you
Apple's
guys,
nice.
we asked David this question. You can't tell him he's wrong.
That's
They
You're
can
Telling
tell
him
me
his
I'm-
answer is wrong. Are
They
you
can tell him
pie-splaining him? I think you're
I-
pie-splaining David.
oh my god, can we hashtag that immediately?
Yes.
They're just trying
pie-splaining.
to. They're trying to refresh my memory, and I think that's okay. Because there's a lot of pies. I mean, there's chess pie. You can make a key lime recipe with other sour citrus besides limes, and some of those are very good. So a key lime pie that's instead made with calamandan juice is very nice.
Wow.
All I'm saying is that you should not have to give an answer without receiving pie. So, Caleb,
Yes, that's right, Caleb. So get your shipping engines ready because it's time to send some pies to the compiler team.
proof.
Hey, can I
And
get a
then-
pie too? I don't even care what pie. Just be a homemade pie and I'm happy. Because I
I'm
don't
pie is
happy.
bake.
good pie.
Homemade,
I agree.
store
Yeah,
bought.
I
Any
don't
pie is
Pie
good
is
pie.
pie.
Send me pie.
So I have one thing to add on the pie subject, then we should probably move on because we're a little bit off topic. But the best pie in the entire universe was made by Emeril Lagasse at his restaurant, and it's banana cream pie, and it's by far the best pie ever. I won't even begin to describe how good it is because I'm hungry right now. But if you get an opportunity to eat Emeril Lagasse's banana cream pie, it's a life-changing religious experience
Where is this?
at any of Emeril Lagasse's restaurants. He's got a couple in Louisiana, and he has a couple here in Orlando, and I don't know where else. Good stuff. Crazy good stuff. Beyond good stuff. So on that note, on that sidetrack note, we should probably move on to interesting Go projects and news as we are starting to run low on time. Somebody's suggesting that maybe we should have our next GopherCon at a place where we can get that pie. And I think that's a really, really interesting idea that we should explore.
I agree.
So let's move on to Go projects and news. Anything interesting other than GopherCon happen in the last couple weeks that we want to bring up?
Are you serious? Did you just ask that question?
I did. But anything exciting outside of GopherCon? I mean, we'll have a whole show
outside.
just about GopherCon.
Outside of GopherCon?
Yes.
No, I'm sorry. I'm still.
Nobody's prepared to talk about anything besides GopherCon.
I'm still getting over GopherCon slowly. That's all I think about.
Yeah, I'm still a little tired. So I ran across a couple news items that were interesting this week. JBD wrote a great article on the scheduler, and that is at rakyll.org, rakyll.org/scheduler. Really good article about how the scheduler works, and I always like those deep dives into the things that are happening underneath. So that was cool. And then there's a cool game engine that I noticed on GitHub about 2 weeks ago that I didn't get to mention because we haven't had a show for a while, and it's called Oak. And that's at github.com/oakmound/oak. And it's a Go-based, pure Go-based game engine. So it does all of its rendering and all of that stuff
OMG,
natively.
Brian,
What?
can we play with it and the Pocket Chip?
Yes, we can play with it with the
Oh
Pocket Chip.
my goodness.
Exactly.
Okay. So exciting.
So yeah, it looks very cool and has very, very few dependencies underneath, which I think is probably the best part. When I was reading, I actually did a couple of their examples and ran code, and it worked really beautifully. And it has very, very few dependencies. The only thing on Linux is an audio dependency. So it's very self-contained, which is kind of slick.
This is
And
happening.
it is happy. And speaking, and we should probably kind of circle back and talk about these Pocket Chips real quick. The Pocket Chip is this amazing, cool little computer thing. It's smaller than a Raspberry Pi, but it's got a little maybe 4-ish inch TFT screen and a keyboard on it, and it's ARM 7 maybe, ARM 7 chip. And it's just so cool. You push a little button and it boots into Linux and it does cool stuff. It plays retro games and whatever. But of course, the first thing I did was boot it up to the terminal. And after typing uname just to find out what it was running, which is Debian, I installed Go, as one does. And it runs Go very beautifully. And it's a slick little toy.
It is so
Yeah.
cute. And you can
Yep.
3D print like cases for it. Did you see that, Brian?
I've got one printing right now, a screen cover with the keycaps and key covers.
I
So
went
yes,
into my garage and I did not see a tarantula, so I might take my 3D printer out of my garage.
You braved the spider just to get to the 3D printer.
I did.
You were awesome.
Well,
Are
she
you
didn't
impressed?
see the spider. Don't.
Just because you didn't see it doesn't
Overestimate.
mean he's not crawling on your back right now.
Why would you do that to me? Why would you
I don't-
say those things to me?
So to
Monster.
give people context, we're talking about the Pocket Chip because that was what was gifted to the GopherCon speakers.
Yes. And it is
Yeah.
just it's a $60 or $70 computer. It's so amazing, so much fun. If you like it all playing with small devices, especially something that is Linux but very, very portable and has a cute little screen and keyboard, then I can't recommend the Pocket Chip enough. It's tons of fun. I really haven't stopped playing with mine since last week. Totally amazing. So back to news. There's a great new book out by Catherine Cox Bidet, one of our speakers from maybe GopherCon 2015, called Concurrency and Go. And that's a O'Reilly book that was just released to print. So I think it's available in electronic form, but not quite yet in paper form. And
In 2
that's
weeks.
very exciting. I had the privilege of reading through an earlier version of it, and it's very well done. Concurrency and Go is a tough topic to hit, and she did a great job on it. So I'm excited that there's another good resource for concurrency out there and a whole book
Yeah.
dedicated to it.
Yeah, exactly. I'm really excited to see a whole book about concurrency, and I pre-ordered it. I'm waiting for my hard copy because it's important enough that I want to hold it in my hand. So.
Mhm.
And I wanted to, on the topic of schedulers, I wanted to make sure we mention Cindy Sridharan. I might have mispronounced her last name, but it's Cindy. And she wrote an amazing blog post about cluster schedulers. It's really well written. She got a lot of praise online for the post. So if you're interested in schedulers, you should read that too.
Oh, that was a very good post. I agree.
Yeah.
Now I know what you're talking about. Good. We should put the link to that up on the show notes too.
I just dropped it. I'm not sure if I'm using the right document, but
Oh, perfect. Yes. Yeah, Cindy's really active in the San Francisco Go community.
yes.
All right. So we like to end our show with Free Software Friday, which is a shout out to any open source group or maintainer or project that you love, that you enjoy, that you can't live without. And it's something that we like to do because we use a lot of open source and we really appreciate all the hard work that people put into those projects and feel like they're kind of thankless. So I will start off by shouting out to Dave Cheney. because we just don't give Dave enough credit for all of the amazing work he does for our community. If you have a question about Go, there's a blog post that Dave wrote that covers it. If you have a problem that you need to solve in Go, he probably wrote the canonical package that fixes that problem, like his package errors. I don't know where we need to start to get his errors package included into the standard library, but if it doesn't happen, I'm going to leave Go for Pony. So just FYI, I'm moving off of Go if we don't get errors in the standard library.
+1 to all of
Dave,
that.
Dave also puts in an unbelievable, immeasurable amount of work into helping us prepare the speakers for GopherCon each year. Not only does he head the selection committee, but then he spends countless hours with each speaker, helping them prepare and getting them up to the A+ level that we expect from our speakers and that we get from our speakers every year. So we can't thank Dave enough for all that he does for our community, and that's why he is my #1 Free Software Friday shout out. Anybody else have a person or a project or a thing that they want to shout out for Free Software Friday?
I want to give a shout out to GoDoc. It's amazing that it's such a neat tool that we have. And for people who are new and don't know, you can run GoDoc on your machine if you're offline, and you get on your browser the documentation for all packages that you have residing in your system. And yesterday I found out that you can write documentation for each of your packages in a separate file called doc.go. If you have a lot of documentation to write, you can put it all in there. So instead of ending up with separate files with tons of documentation in those files. It's really neat. I didn't know that.
Very nice.
I want to shout out Brian and Eric. You had to have known that this was coming. GopherCon was amazing. Every detail was on point. The sessions were awesome. That contributor day, oh my God, why is the Go team not doing those like once a week? It was so good.
That was great. The contributor thing was amazing. I don't know if they had a final count, but I think more than 100 people got onboarded to contribute to Go, and I don't know how many contributions there were, but it was a lot, and so many people were excited about that.
We found bugs.
Oh,
that's fabulous.
I mean, you get new people using Go, and they do stuff that you hadn't realized that someone would try, and you get bugs.
This is very cool.
That's awesome. So we do have some statistics from Jess Frizzell. 44 new open CLs, of which 22 were merged as of 2:46 this afternoon. That is awesome. Great news. And we can't even talk about this without me thinking about Brad Fitzpatrick's picture of him with his Looks Good to Me shirt on and a handful of gophers stacked around him as he was helping us remotely take care of business, which is awesome. So we should definitely thank Steve Francia for putting that whole thing together, and everybody who contributed in the room, from the mentors all the way to the people who learned how to contribute the first time. It was fabulous.
Yeah, it was so good.
Yeah, we are talking about a few of the meetup organizers were so taken by the whole exercise that different people went up to Steve separately and told him the same thing, which is we should be doing this a few times a year, like just getting meetup groups going through exactly that workshop. So it might happen. It might be happening.
It actually reminds me, one of the Arizona meetups I just saw on Twitter today, they're actually going through the same exercise at their meetup this coming month. Phoenix. Yes. Brian Downs. Thank you, Phoenix, for doing this exact same thing. That's awesome. You got to love Brian Downs for being on top of his meetup organizing game. So if you're in the Phoenix area, go to the next Phoenix meetup, and you can get that same experience.
So my wish list is to go through that and have someone from the Go team or one or two people going through the CL submitted, so we can have that quick feedback loop.
Mm-hmm.
Anyway.
That's awesome. All right. So anybody else have a Free Software Friday shout out that they want to make?
Dave, do you have one?
Day in, day out, I'd have to say MacPorts, because I use a Mac all the time, and I use the Unix tools all the time, and a lot of them on a Mac. These guys are getting a lot of leverage off of the fact that they're packaging other open source software, but it's a lot of work. I have, helped debug a few of them, and just all the packaging work is a big deal.
Now, I have a question for you on the MacPorts, since we've got just a moment. How do you find it in terms of quality and kind of completion? I used MacPorts maybe 2006 or 2005, quite a while ago, and abandoned it for Homebrew because MacPorts just didn't seem to be that stable. Do you have any issues with MacPorts, or is it solid for you?
It is more solid now than it was. I don't know why I didn't do Homebrew. Back then, I don't know if there was Homebrew. There was Fink. And I tried both, and I ended up settling on MacPorts. It's better now. They do a better job in terms of the dependency tracking and the rebuild tracking and the cleanup. It used to be just more often you'd get wedged and have to uninstall a bunch of stuff and reinstall clean. And I can't remember the last time I had to do that. And at the time, as late as 5 years ago, 2012, 2011, we were hosting a big old track thing on it. And we were hosting track on another box, but I was actually mirroring the server on my laptop. And it was using MacPorts to get me everything that I needed. And everything that I needed included, track and Python and SQLite and Mercurial and the whole tech tool chain. And this was for this crazy website that would run tech. It would use Emacs and tech. Emacs in batch mode and tech to do processing to turn your code into something formatted in a pretty mathematical style. And it worked.
And it worked. It's a miracle. All right. So I think that wraps up our show today. I'd like to thank David Chase for joining us and going deep into compiler land. I probably learned more in the last hour than I've learned in years on compilers. I really appreciate that. And thanks to everyone who's listening and the folks out on the Slack channel. Thank you so much. If you enjoy the show, be sure to share it with fellow Go programmers in your meetups, in your office, all across the land. And you can easily subscribe by heading to gotime.fm and subscribe to our weekly email, which is coming soon. You can follow us on Twitter at GoTimeFM. And if there's anything you want to discuss on the show, or if you've got a guest that you think we should have, head over to GoTime or github.com/GoTimeFM/ping and open an issue. So with that, thanks everyone. We really appreciate it.
Thank you.
Thank you. And thank you, Dave.
You're welcome. Thank you for having me.
All right, that's it for this episode of Go Time. Tune in live on Thursdays at 3 p.m. U.S. Eastern at changelog.com/live. Join the community and Slack with us in real time during the shows. Head to changelog.com/community. Follow us on Twitter. We're at GoTimeFM. Special thanks to Fastly, our bandwidth partner. Head to fastly.com to learn more. Also, Linode. We host everything we do on Linode servers. Head to linode.com/changelog. GoTime is edited by Jonathan Youngblood, and the theme music for GoTime is produced by the mysterious Breakmaster Cylinder. We'll see you again next week. Thanks for listening.